Here I am to finish up the problem that I started to talk about last time. It's open absolute value x minus 3, close absolute value plus 1 equals 3x minus 4. Okay, so again we need to isolate the absolute value first, so I subtract 1 from both sides, and that leaves me with the open absolute value x minus 3, close absolute value equals, and if I subtract 1 from both sides, this becomes 3x minus 5. Okay, the absolute value is isolated. Let's talk about how we have to set up these two equations. Now, if x minus 3 equals 3x minus 5, then that would satisfy this equation. If that were true, assuming that, this 3x minus 5 is positive. So let's set this up. We've got x minus 3 equals 3x minus 5. Now, another way that these could be equivalent is if x minus 3 is equal to negative parentheses 3x minus 5, because then we'll take the absolute value of x minus 3, it'll become positive and be equal to 3x minus 5. So let's express that as x minus 3 equals negative 3x minus 5. And I want to show it amounts to doing the same thing that we did over here. We set x minus 4 equal to positive 2, and we set x minus 4 equal to negative 2. Well, we're still doing the same thing. X minus 3 got set equal to a way of thinking of this as positive 3x minus 5 and negative 3x minus 5. Okay, let's solve these two equations. I add 3 to both. I'm going to go ahead and move this x over here, and I'm going to move this 5 over here. So I'm going to subtract x from both sides, and that leaves me with 2x. I'm going to add 5 on both sides, and that leaves me with 2 over here. And then divide both sides by 2, and x will equal 1. Okay? Here, the first step I'm going to do is distribute this negative sign, so I have x minus 3 equals negative 3x plus 5. Okay, I'm going to move this negative 3x over, and move this negative 3 over by adding 3x and adding 3. Add 3x to both sides. I have 4x equals, add 3 to both sides, 8, or x equals 2 by dividing by 4 on both sides. Okay, so I have two answers. I've done here, I isolated the absolute value, so that was step 1. Step 2 was to set up the two equations. That was completed right here. Step 3 was to solve both equations. For this one, step 3 amounted to this, and for over here, step 3 amounted to all this. Now the final step, to verify the solutions, which I know sometimes seems like a pain. It's like, I did all this work, why should I verify the solutions? Well, in this particular problem, it's important to verify the solutions because I'm going to give you a little spoiler alert. One of these does not work. That won't always be the case when you solve an absolute value equation like this, but in this particular case, I've designed the problem so that one of them will not work. Now we need to figure out which one it is. So let's start with x equals 1. So I have the absolute value, so I'm on step 4, verify the solution, of 1 minus 3, close absolute value, plus 1, equals, hopefully, 3 times 1 minus 4. And again, all I've done is just plug in the solution into the original equation. So this is the absolute value. 1 minus 3 is, of course, negative 2. Close absolute value plus 1 equals question mark. 1 times 3 is 3. 3 minus 4 is negative 1. Absolute value of negative 2 is, of course, 2. So 2 plus 1 equals question mark negative 1, and we found the solution that does not work. 2 plus 1 is 3, which is not equal to negative 1. So I know that x equals 1 is not a solution. Let's make sure that this x equals 2 is a solution. Sometimes it could be that neither of the solutions we find is a solution. So let's plug it in. So we have absolute value of 2 minus 3, close absolute value, plus 1 equals 3 times 2 minus 4. 2 minus 3 is, of course, negative 1, so this is absolute value negative 1 plus 1 equals 3 times 2 is 6 minus 4. The absolute value of negative 1 is, of course, 1, so I have 1 plus 1. Oh, these should all be question marks here. Equals 6 minus 4 is, of course, 2, and 1 plus 1 is 2. So this solution x equals 2 actually worked, and this solution x equals 1 is not a solution. So I'm just going to go ahead and cross it out. So the solution to this question is simply x equals 2. Whereas over here, there were two solutions, x equals 6 and x equals 2. On this equation, there was only one solution. And we call this solution x, or this non-solution x equals 1, an extraneous solution. And I'm going to discuss that in the next video.